Assalamu alaikum students, how are you all? Unit number 7, introduction to trigonometry we were solving, and so far we have done 7.1, 2 and 7.3, and its question number 4 is our task today. 4 and 8 most probably. In the question number 4, see the statement: in which quadrant theta lies when? There are 6 cases, but we are following ALP syllabus here. Then there will be second and sixth part in it. In which quadrant theta lies when? The second part, cos theta less than 0. Less than 0 mean anything less than 0 mean negative, and sin theta less than 0 is anything less than 0 is negative. So first let me explain the 4 quadrant system. You are already familiar with what are the trigonometric functions and ratios, and what they are equal to, and what is the angle theta here. Let's discuss about these things first. So the first one is 4 quadrant system. You are already familiar with it, that a complete circle, as you know, is divided into 360 degree, and there can be 4 possible rectangles, or you may say right angle in it. And the 4 quadrant system, we have 4 right angles like this: 0 to 90, then 90 to 180, adding 90 again, 180 plus 90, 270, adding 19, and at the end the 360 will be the result. And but our topics not here the angles. They are our topic also when we'll discuss about trigonometric ratios. But first, the 4 quadrant system: first, second, third and 4. They are the 4 quadrants. And what are the trigonometric ratios is our next topic now. The trigonometric ratios are sine of theta. Sine is our trigonometric ratios where theta is any angle. It can be changed. It can be in the form of x, phi or psi something. They are the cos theta and tangent theta. The theta is like this. Trigonometric ratios: sine of theta, cos of theta, tangent of theta. And what is sine of theta equal to? We will discuss their reciprocal after this. The trigonometric ratios always hold in right angle triangles. For example, if I have a right angle triangle in the xy plane, name it as in a right angle triangle we have 3 sides: adjacent, perpendicular and the hypotenuse. In a right angle triangle we have 3 sides. They name as the side opposite to 90 degree is named as hypotenuse. The side opposite to, let me write these sides. In the class 9th, the chapter was Pythagoras theorem. You have discussed these about these sides. In a right angle triangle, the side opposite to the 90 degree angle is called hypotenuse. The side along the right angle is called base, and the side along the 90 degrees is called perpendicular. Now, what are the trigonometric ratios in right angle triangle? That sine of theta is equal perpendicular over hypotenuse. Perpendicular over hypotenuse. The value of sine of theta is perpendicular over hypotenuse. In this small right angle triangle, you can see right in front of 90 degree is hypotenuse. It means here in this case the hypotenuse is 5, perpendicular is 4 and the base is 3. So discuss about this triangle, we can write it as perpendicular is 4 and hypotenuse is 5. And cos of theta is equal to base over hypotenuse. You need to learn them. Base is 3 and hypotenuse is 5. Similarly, tangent theta is perpendicular over base. The perpendicular is 4 and the base is 3. So this is how you will know about the trigonometric ratios. You should know about their basics, that in a right angle triangle, angle opposite to the 90-degree, hypotenuse, base, perpendicular, and then sine of theta is equal perpendicular over hypotenuse, cos of theta equal base over hypotenuse, and tangent of theta equal perpendicular over base. And now, after knowing about the trigonometric ratios, let's have another general example. If I have a right angle triangle, say A, B and C, then you know at angle we have right angle, opposite to B is hypotenuse, along this is base, and this side is perpendicular. Right angle triangle. So in triangle ABC, sine of theta is equal perpendicular over hypotenuse, perpendicular is BC and hypotenuse is AC. Cos of theta is equal to base over hypotenuse, it is AB over AC. And tangent theta is equal to perpendicular over base, it will be BC over AB. And now the reciprocal identities. And the reciprocal identities in the trigonometric ratios is the converse of the other. The sine theta, its reciprocal is cosecant theta, and it is equal to the opposite of sine. As sine is perpendicular to hypotenuse, then cosecant will be hypotenuse over perpendicular. The opposite of cos theta is secant theta. Secant theta, as cos theta is base over hypotenuse, secant theta is hypotenuse over base. We will deal with these trigonometric ratios in our upcoming questions and exercises. And tangent theta, its opposite is cotangent theta, and it is equal to base over perpendicular. We will discuss more about these trigonometric ratios. There are more formulas, but first let's complete question number 4. In the fourth quadrant system, the first quadrant contain all trigonometric ratio positive. It means sine positive, cos positive, tangent, cotangent, secant, cosecant, they all values when they have angle 0, 10, 20, 30, 40, 60, 70, 80 or even 90. Till 90 it means the trigonometric ratios lies in the first quadrant. There will be all positive. In the second quadrant, only sine and cosecant are positive while rest of them are negative. In the third quadrant, only tangent and cotangent are positive while the other are negative. In the 4, cos and secant are positive while the all other quantities are negative. Now our first question is based on it. See that the second part, cos negative and sin negative. Cos negative and sin negative, where cos and sin both are negative. If you see the first quadrant, in the first quadrant all trigonometric ratios are positive, so cos negative and the sin negative will not be there. Cos negative and sin negative. In the second, sin is positive but cos is negative. In the third quadrant, tangent and cotangent are positive while the other are negative. In the 4, cos and secant positive while other are negative. It means the quadrant number 3 is a quadrant where both sin and cos are negative. So only write that third quadrant. Then in the sixth part, sin negative and secant negative, very similar. Sin and secant, it will also lie in third quadrant. Because the only difference here, sin is sin and cos is reciprocal. Note it that sin and its reciprocal are positive in second, while other all quantities are negative. In the third, tangent and cotangent positive and other quantities are negative. Let's discuss another case, not in the ALP syllabus, but you should know sin is positive, tangent is negative. Sin is positive, tangent is negative. So sin theta is positive in second, where tangent is negative, so it will lie in the second quadrant. Number third, secant positive but sin negative. Secant is positive and sin negative in the fourth quadrant. And fifth one, cosecant positive, cos positive. They will be in the first quadrant because in the first quadrant both are positive. Fourth one, cos negative and tangent negative. Cos and tangent are negative in the second quadrant, so we will write second here. So lots of about trigonometric ratios we have discussed in this lesson, and a little about the quadrant system and the where these trigonometric ratios are exist. So we will see more introduction, more concept and the problem related to trigonometry in our next lessons. Thank you so much.